prospect of gas getting up to $4 a gallon this summer. Even at that, if you go in and buy bottles of water in a convenience store and buy enough to make a gallon, you'll be paying more than that gallon of gas you get at the pump. That day has come. That's how important water is. So we became concerned a number of years ago about what was happening to the water in the Illinois River watershed in eastern Oklahoma. Particularly concerned about that for two reasons. One was the legislature had designated the Illinois River and several of its tributaries, including Flint Creek and the Barren Fork, Peach Eater Creek and others, as scenic rivers. A special status afforded under the statutes of the state of Oklahoma, saying that these belong to all of us. They are part of our heritage. They're beautiful rivers and that they need to be preserved. And also, the second reason is, these are rivers that are close to where I grew up. And I used to swim in the Illinois River. I used to swim in Lake Tenkiller and the Barren Fork and Flint Creek. I went to school at Northeastern over in Tahlequah, and I tell audiences back there that I majored in river, which they understand, but basically it means I spent more time at the river than I probably should have. They may actually have a river major today, but they didn't back then, I just say that. But those were beautiful streams. My wife Linda is here with me, and we got married while in college, and had our first child, not Robert, but our daughter Mary, was born while we were living in student housing at Northeastern State College back in the 60s. And we used to take Mary with us picnicking and swimming and dipping, really. She wasn't swimming. We dip her in water, which was pretty cold, and she you know what babies do. And Robert also, as we grew up, would canoe and swim in the Illinois, and it simply is not the way it used to be. And the reason for that is because of the change in poultry production over the years. You know, I have this mental image that probably comes from The Wizard of Oz with Dorothy and Auntie Em and Uncle Henry out in the barnyard throwing grain down on the ground so the chickens can eat, and then they go in the barn and roost at night, and in the morning you go in and look for eggs and that kind of stuff. That's the old way. That's the way chickens used to be produced. Robert told me, by the way, that he was worried that we had chicken fajitas here tonight. I said, the more of them that we kill and eat, the better off we are. Don't worry about it. That's not the way we produce chickens today. We have poultry houses today that house up to 25,000 birds at a time. And their growing season is like 6 weeks. 6 or 8 weeks, and they go from chicks to full-grown birds. So they will turn over at least 4 to 5 crops of birds in a year. So that's 100 to 125,000 birds in a single house in a year. And most poultry farms will have from 3 to 20 houses. So you're talking about hundreds of thousands to millions of birds in a single operation. And they produce what we euphemistically refer to as poultry litter. You all know what poultry litter is? Okay. We had a lawyer for the other side say something to me once, and I said, that's bull litter. You know, it's the same thing. The poultry litter is high in nitrogen and phosphorus, which makes it an excellent fertilizer. You put it down on the land, and you can grow just about anything. It's good. Plants need nitrogen and they need phosphorus, not quite as much phosphorus as they need nitrogen. That's one of the problems. The content of the poultry litter is 1-to-1, the ratio of nitrogen to phosphorus, and the needs of the plant are 8-to-1. Plants need 8 times more nitrogen than they need phosphorus. So a lot of the phosphorus, once you put it down on the ground, is being wasted. And also the plants take up nitrogen easier than they take up the phosphorus. So it's much easier for the land to become saturated in phosphorus than it is nitrogen. The problem is they put down so much of this litter, and the land is already saturated with phosphorus, that when it rains it runs off. And it does just as good a job fertilizing the water as it does fertilizing the land, and grows algae. What the scientists at Oklahoma State University refer to as eutrophication. That is increased algae bloom, which sucks the oxygen out of the water. It changes the biota. It changes what kind of animal life can live in the water and what can't. So you're trading trout for frogs, or turtles or snakes. And it completely, eventually, will suck all of the oxygen out and destroy a river or destroy a lake. In the summer months today, Lake Tenkiller, which all of these tributaries feed into, in the summer months, Lake Tenkiller is 70% oxygen dead, which means fish can't live in it. Fish, oddly enough, fish have to breathe, and they breathe water with oxygen in it, and they strain the oxygen through their gills. And there's a thin band in Lake Tenkiller, a thin band in the summer months that has enough oxygen for the fish to survive in, and it's not too hot from the sun. And as that band gets thinner, fewer and fewer fish will be able to survive. In my day, people came to Lake Tenkiller from other states to scuba dive. It was a destination site for scuba divers from around the country. They drove to northeastern Oklahoma to Lake Tenkiller because of the clarity of the water. Now there's still scuba diving at Lake Tenkiller, but they don't come in from other states to do it. It's not a destination site anymore because you can't see more than that far ahead of you when you get into the water. And that's a very sad thing. There are other environmental problems, some of which we've talked about and some of which we haven't. The feed, which goes to the poultry, which is provided by the companies, also contains growth hormones. It also contains arsenic in one form or another. It contains other trace metals that are not naturally occurring. If they were eating something else, they wouldn't be getting this. And we honestly don't know what the long-range impact is going to be of growth hormones provided by the companies in the feed, being deposited on the land as fertilizer, and then being eaten by the cattle that graze. They eat the plants, and we don't know what the impact of that's going to be. We do know that the impact of arsenic is very dangerous. And we also know that municipalities that use water, and there are 33 different municipalities and rural water districts on the Oklahoma side alone that take water out of the Barren Fork or the Illinois or other sources, they have to add more chlorine to treat the increased algae growth in the water to make it taste good, to make it smell good. Otherwise, with too much algae in it, it's not going to taste good, it's not going to smell good, it's not going to hurt you, you just don't want to drink it. It doesn't smell good, it doesn't taste good. So they put more chlorine to treat it, and the more chlorine that you put in, the more trihalomethanes you're going to produce, and trihalomethanes are chemical byproducts of the chlorine that are carcinogens. So the people who are taking water in Tahlequah and Westville and Stillwell and rural water districts have a Hobson's choice. They can either have their water not smell or taste as good because of the algae, or they can slightly increase their cancer risk because of the chlorine that's being added to treat it. And that's an unacceptable choice as well. We just completed, and we're waiting for a judge's decision on another aspect of the massive poultry production that we raised recently in an application for temporary injunction, and that is the bacteria that's contained in the waste that we found as we were doing our sampling to get ready for the environmental case that's going to come next year. We sampled edge of field, we sampled soil, we sampled streams, we sampled different places along the river looking for the trace metals that we're going to be talking about next year, the phosphorus and the other chemicals that make a chemical fingerprint that we can say this indeed comes from the poultry company. we started discovering enterococci, fecal coliforms, and E. coli. And we traced those back to edge of field and to the poultry litter itself.